To write the linear factorization of this polynomial, it's going to involve a lot of factoring. So the first thing we want to do is say, well, how can we factor x to the fourth minus 14x squared plus 45? Now we know that's a trinomial, and we know that a quadratic trinomial can be factored down into a product of two binomials. So let's start there. Now, again, I was saying quadratic because x times x is going to give us x squared. But we don't have an x squared. We have an x to the fourth. So we can obtain an x to the fourth by simply just raising our powers to an x squared times x squared. That's going to work because our middle term is going to be an x squared. That comes in handy when we're go ahead and multiplying this out and combining our like terms in the middle. Now, the last number is going to give us 45. Remember, our last two numbers in our binomial need to multiply to give us a positive 45, but add to give us a negative 14. Since my last number is positive, but this term is negative, that means both of my factors both need to be negative, because a negative times a negative is a positive, negative plus a negative is still a negative. So hopefully you can see that that's going to be a negative 9 and a negative 5. Now, this is in factored form, but it's not in linear factors. So the next thing we need to remember is how do we factor these further down? That's going to come into the difference of two squares. Okay, so hopefully you recognize x squared is a square term, 9 is a square term, so we can factor that one down rather easily. However, x squared minus 5 is not so obvious, but hopefully you recognize that we can rewrite a 5 as a square root of 5 quantity squared. Now you can see it's written in the form of a squared minus b squared. So therefore, the factored form in this case is going to be an x minus a square root of 5 times a x plus the square root of 5.